Okay. So also FYI, first exam over this unit will be Wednesday of next week. So you got a week from today, okay? All right, so in this unit, section 1 dealt with functions in the form of an equation. Section 2 was functions in the form of a table. And then we started functions in the form of a graph. We did not complete that unit 1.3. We're going to pick up there and we'll get this one completed today. All right, so we're looking at a graph. So when we have a graph, we have a vertical axis and we have a horizontal. Which of the two is always my function? Up and down, side to side. Up and down. So this is always your function. One thing I did notice overall, and I teach 2 functions classes. So when I grade it, I'm thinking of both classes. So not necessarily, I don't know which one this occurred more in, is what I'm trying to say. But overall, students were able to identify or define the function and the variable off of the table better than they were off of the equation. So the graph is kind of similar to the table in that you know where to always look. Okay, so we're going to go ahead and read this and define what our function is and what our variable is. So if it asks you to define or identify, that's what it's asking for. All right, when you purchase a home by securing a mortgage, the total paid towards the principal is called your equity in the home. So basically, equity is the part of the home or value that you own. It's not what you still owe the bank. The graph in the figure below shows for a certain 30-year mortgage, the equity in dollars accrued after a given number of monthly payments. So hopefully you get to a point where you can read that and determine what the function and variable is, but if not, go to your graph. We know this is always the function, which it says equity in dollars. So I'm going to call the function E because they don't give me a specific variable to use or a letter to use. So we know this is your equity and we know we're talking dollar amount. So then I know my variables, the horizontal axis, and it says number of monthly payments. And I'll just call it N. This is your number of payments which are done monthly. Okay. Now, notice up here it said it was a 30-year mortgage. Down here they have this in terms of months. But of course, we know that 36 months is the same thing as what? 30 years, because 30 years times 12 months in a year is 360. So this is the same thing as 30 years. It's just they represent it in the number of payments. Okay. All right. So this is how you read this graph. So when I'm looking at this, when I purchase this home, I don't have the purchase price, so I go to the bank. So notice it's in zero. I've not made any payments, and it appears that I'm getting a loan for the full amount. Because if I had, like, say, put $50,000 down, then my graph would have started here because that's how much I put down, but it's right in the corner. So as we go, for every month that I make a payment, my equity or the amount towards the principal is going to grow and grow and grow and grow because I'm paying my home off. Okay, so that's how we read this graph. All right, so in this section or unit as well, or this section of the unit, we are talking about concavity. So if you need to pull out page 10, we talked about this last week, and now we're going to be applying the importance of being able to decipher what the concavity tells us. Okay. All right. So it starts out and it says, is this graph concave up or concave down? So is this graph concave up or down. It is up, because if you extended it, it's like cups up. So we know it's concave up. But then after deciding that, now you need to know how to explain that. Well, if you go back to this page and look for one that's similar to this, it would be this right here. But if you just write the function is increasing at an increasing rate, or if you just write the graph is increasing at an increasing rate, that is not sufficient. You have to be specific to the problem. So the function, right? Well, when I explain this, I'm not going to write the function. I'm not going to write the graph. I'm going to come up here and see what function represents. What represents equity. So instead of writing the function, I'm going to write the equity is, and then this is where we then read the graph. As we go left to right, it's going upward. So we know that this function is doing what? Increasing, which makes sense because the amount of the home I own is increasing at, and then this is where we say it's increasing at an increasing rate or a decreasing rate. It's all about what's going on here at the end. Is it leveling off? If it's leveling off, it's a decreasing rate. If it's not leveling off, it's an increasing rate. So which is this an example of? Increasing. So anytime again, when I ask you to explain, I expect complete sentences. And yes, I did have to take off some points for people not putting periods on the end of their sentences for that quiz. Okay, so be careful of that. But when I ask you to explain a concavity question, here's what I'm looking for and what I will grade. I want to look that you tell me what the function is. So that's going to be problem specific. You need to tell me what the graph is doing and at what rate. So those are the main three components that I'm looking for you to be able to tell me. All right. This says, when will the value of the equity reach $150,000? Okay, so they gave me $150,000. So were we given function or variable? Function, because 150,000 is dollars, which that's over here. So we were given function. So when it says when, it is asking us to find when is a like how many payments in. So it's asking us to find the variable. Okay, so I'm going to locate 150. And then I'm going to try to draw as straight of a line as I can till I get to the graph. And then I'm going to see where that is on my variable axis. Now, this did not land exactly on one of the numbers that's given. So we're going to do an approximation. And so just know on an approximation type question, I'll have some flexibility on what the answer could be. I know it's more than 240 monthly payments, but less than 300. It's not even halfway. So I would probably say when approximately, I'd probably say approximately 250 payments. So if somebody else gave me 255, I'll have some flexibility with that. But if they gave me 150, well, 150 is down here. So no, I'm not that flexible. Okay. So here's what it's asking for here. Don't just say approximately 250, because I don't know what we're talking about. Be sure that you label payments. Always, always, always label your answer. All right, what is the average rate of change? Okay. So on your quiz with an average rate of change question. So let's remind ourselves that it's been a long weekend. To find the average rate of change, we always do the change in function over the change in the variable. Now, y'all, I can tell you right now, I had several, enough for me to remember that on the quiz, I had some that even wrote this, but then when they actually put the numbers, they flipped it. They put the variable on top and the function on bottom. So be very, very, very careful of that, okay? All right, so this says from 120 to 240 monthly payments. All right, so here's 120. And it goes with, it appears, 50,000. And then it says 240. It doesn't land, it looks like close to maybe 140,000 is what we're gonna use. All right, so it's the change in function. So on our graph, we go top down, so we would do 140,000 minus 50,000. And then we would do 240,000, not thousand, sorry, 240 minus 120. Now, if you want to put this in or this in your calculator here and go straight to the answer, I'm fine with that. You do not have to show this step right here, which would be doing the subtraction separately, and that is the 90,000 over 120 payments. So you don't have to show me this. You could go straight to your calculator, alpha y equals 1, and do 140,000 minus 50,000 over 240 minus 120. Now notice I get the whole number 750. Okay. How could I write 750 as a fraction where it has a numerator and a denominator? It's over 1, right? Which is what we want, right? A unit rate. So this is 750 over 1, and then you have to label it. So on top, we're talking about money, $750 over 1 payment. Now, I had several people on the quiz. If it was a question set similar to this, they just gave me $750. So I did take a little off. Now, I did have some that wrote it this way. These two mean the same thing. So if you gave me that, I would give you full credit. But get in the habit, I want it always in unit rate form with it over 1, and then you have to be sure that these are labeled. So I'd need to see dollars on top and payment on the bottom, okay? Then it goes on to say, explain what this means. All right, so remember, we're only talking about the graph from here to here. And what we're saying is, at my 120th payment, my equity is $50,000. Then we have our 121st payment, 122nd payment. So now what we found is this part of the graph, every month, I am earning $750 towards my equity. but it's per month. Okay? All right, so how would I explain that? So what is the equity from here to here doing? Increasing. So I would say the equity is increasing. And I can look at the graph and see that. And I also know it from here because this is a positive number. If we would have gotten a negative, then we would know it's decreasing. But since this is a positive number, it is increasing. And what is it increasing? $750 per month. And then I need to also include that this is between 120 and 240. Oh, I'll say payments. You could say months or payments. Because if we found the average rate of change here, it could be different than 750 a month. It might be the same, but it's not guaranteed. We only found the average rate of change between those two values. Okay. All right. Use the graph to estimate the amount of the mortgage. So we're going to estimate the amount of the mortgage. So this is basically the full amount when I make my last payment and the bank says you now own this home. Here's 30 years, right? So this is my last payment, correct? So at 360 months, I make my last payment. So now I basically own the home, which is full equity. So what would you tell me that the amount of the mortgage was? $350,000. Right? All right, let's do another one, and then we're going to get into sum of 1.4. All right, so I want you to read this and look at your graph, and I want you to define the function or identify the function and the variable. All right, this one gave us a little bit more information even up here because it says the graph below shows the population N equals N at D. So they give me that functional notation here. So over here I look, here's my function. So what letter did you use for your function? Yeah. Now, I will say I had several on the quiz that would identify or define the function of the variable, but they didn't give me the letter that it was associated with it. So be careful of that. So N is population, but I want to look at population of what? So it is population of animals, and they're talking in the thousands. So it would be population of animals. And then this is 3,000. So when I see this 40, that doesn't mean 40 animals. It means 40,000 animals, right? Now this is a particular species on a protected reserve, so just be aware of that, but that's sufficient for your definition. All right, what did you use for the variable? D, and I look at this horizontal axis and it tells me that that is the date. So that's whatever year it was. All right, find N at 1968. All right, what was given? Function or variable?
Oh, variable.
Be careful. Function is a number that represents population of the animals in thousands. 1968 is a date. So they gave us the variable. So that tells me we need to find the function at that date. All right, so I'm gonna look up here and I'm gonna find 1968, which is not a number, but I have 1965, 1975, so this has to be 1970. So we're looking at 1968, so it would be more here. So if you write equals 40, I'm gonna count some points off. Why? Because it's 40 what? Thousand. So I need to either write 40,000 animals. You can write that. Or you could write 40,000 animals. Either way is sufficient. This is okay as well. But always, 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 don't just give me a number. Tell me what it is that it represents. All right, when did the population reach 80,000? Okay, so what was given on this one? Okay, when we're talking about 1,000, that's a population. So this time we are given the function. And so they are asking us to find the variable, which is the date. Okay, so 80,000. Okay, that's what I'm looking for. All right, so here's 80,000. Right, it looks like it hits that right on. We're gonna say it does. So when did this occur? Okay. So if it doesn't ask you to explain, then this is okay. If it did, then you could say something like the population of animals reached 80,000 in 1980. And then of course, this is what you had to find. Now, if you're sitting there going, okay, when do I need to write a sentence and when is it okay not to? If it says explain, then it's always yes, give me a sentence. If it doesn't say explain, then I won't count off points if you don't put it in a sentence form, but you do need to always tell me what you're talking about. Don't just throw a number at me without at least telling me what it represents. Okay. All right, so The next question is talking about concavity. So when you look at this graph, is it only concave up or concave down? I see both, don't you? So let's say we start over here at the far left. So the first part of the graph, would you say that's concave up or concave down? Because if you got rid of this and only looked here, you can see it's concave up. So we're going to define it being concave up. What year did that start?
1965.
That's when my graph starts, so we'll go 1965. Now, here's another place. I'm going to say that that concavity changes right here. If you chose somewhere a little above or a little below, I'll have some leeway on a test, okay? But we're gonna say that it changes concavity right there, which is 1980. Now, here in a minute, we'll finish up and talk about from 1980 on. But this also wants us to explain what that concavity means. Okay, we're going back to this. Anytime you have to explain concavity, then that is what I'm looking for. Again, don't say the graph, don't say the function. And we are confining what we're looking at to this part of the graph. Oops, you can't see. There, this part. Okay, so when I explain this, I'm gonna say the, but I'm not gonna say function. What is the function? Population of animals. I have to be problem specific. So the population of animals is, all right, what is this doing from left to right? It's increasing. Now, we're not looking at the full end of the graph right now. We're just looking at where this concavity would change. So what is the graph doing at this point right here? Is it leveling off yet? No. So what kind of a rate would we have? At an increasing rate. And again, these are the pieces I'm looking for. Okay, then at this particular point, the concavity changes. So now we have concave down. And that would start at 1980 and go till when? Yeah, my graph stops at 2005. So this part of the graph is cups down. You can see, sorry, it's cups down, so that's why it's concave down. So we're still talking about the population of the animals. It's going up, so it's increasing, but it's leveling off. So what would the rate be? Decreasing. So the population of animals is, and you told me increasing at A, and since it's slowing down, decreasing rate. Okay, all right, so before we get to D and E, so last week when we talked about concavity, we said, okay, this point right here, when it switches from concave up to concave down, this point was called something specific. Does anybody remember what that was? Flip back and inflection point. So at this point, this is our inflection point. Now, does anybody recall What specifically happens at the inflection point? It's either increasing or decreasing. This one's increasing. What? What'd you say? It does change concavity, but what is the population of the animals doing at that particular point? Increasing not only rapidly, but the fastest at that point. So if it's an increasing function, then at the inflection point, that's where your function is increasing most rapidly. If it was decreasing graph or function, then at the inflection point is where it's decreasing most rapidly. So if we were talking about investments and it was a decreasing, at the inflection point, that's where you're losing money the fastest, which we want it to hurry up and slow down, because that's not a good thing. Okay. All right. Just wanted to remind you of that before we answer these questions. Okay. When does a point of inflection occur? So basically I am asking your inflection point occurs when. It says when, so it's going to want to know a date. 1980. And remember, we're talking about the population of animals. So it wants me to explain how this point may be interpreted in terms of the growth rate. So it's increasing, so we know the population is growing, and it's growing how at that point? Most rapidly or the fastest. So if I was asked to explain that, I would say the population of animals is growing, or you could say increasing, most rapidly in 1980. And I'm going to go ahead and put inflection points, so just so you remember that 1980 is your inflection point. All right, E. What is the environmental carrying capacity of this reserve? Okay, this is basically saying, is there a limiting value for this population? Now remember, limiting value is if it hits that limit and then just basically stays that number. So we see it starts, that population starts slowing down, and then it appears it's just going to start coming out and be a straight line, which means there's not going to be any more growth. So it appears how many animals would be your limiting value? So it would be 140. You would either write 1,000 animals. You could write it that way. If you just give me 140, nothing else, I'm going to count off. You could write 140,000 animals. If you just give me 140,000, I'm going to count a little off. You got to tell me what we're talking about. Okay. All right. So that finishes 1.3, which will be scheduled and will be due on Friday. We are going to do a little bit of 1.4. So we've done functions as equations, functions as tables, functions of graphs, and now everybody's most favorite whole bunch of words. So yay, we got to figure out what these words mean. All right. So I'm going to break it down to you as much as possible, but I will tell you, you're not going to get better or more comfortable with something unless you practice it over and over and over and over again. So that means you might do WebAssign and do it again and do it again and do it again and do it again. It's the only way you get better at it. But saying, I don't like it, I'm going to do as little as possible and walk away, you're not going to get better at it. Okay. All right. So here's example one. You currently have $600 in a piggy bank, and you're gonna add $33 to the bank each month. Find a formula. So now we are writing the equation. Find a formula that gives the balance B in dollars in the piggy bank after T months. All right. These are going to be my function and my variable. I got to figure out which one. So I'm going to write function, variable. Which one do you have to know first before you can find out the other one?
Function.
So if I wasn't even defining, which one would you go, oh, if I knew this, I could easily calculate how much money I have? The number of months, which is the variable, right? So that tells me the variable is independent. The amount of money is dependent. Our function is always dependent. So that tells me that the function is B, which is your balance. And this is in money, dollars. So my variable T is number of months. All right, so I know my function B equals, and now I've got to come up with a formula that's going to have some numbers and the variable T in it. Okay. All right. What's a number that you know you have this amount of money and it wouldn't matter what happened, wouldn't matter how many months came and went, you still have this amount of $600. This is what we call our fixed amount. So you start out with $600, right? Then it says you add, so we're going to add $33 each month. So that means $33 per month. So at 1 month, it would be an additional $33. 2 months would be $66. So we know we're going to multiply this times T, because that number will increase as the months pass. Okay. I'm going to go ahead and write it using functional notation, B at T. Now, if you leave the $600 in front, it's perfectly fine. We typically mathematically put the term with the variable up front, so I'm going to switch them. But if you did not switch them, I won't count off, because 600 plus 33T is the same thing as 33T plus 600. And that's all that problem asks me to do, is find a formula. It's not giving me any amount of months. I don't have to do any calculated. It just said find the formula. So we're done with that. All right. 2. You went out and bought a really big TV. Okay, 60-inch plasma TV cost $3,000. And you bought a new DVD player for $643, surround sound $650. $323 for a nice stand to put all that stuff on there. Since getting the nice home video system, you subscribe to a cable TV package, which includes a bunch of channels and costs $126 per month. So this is your per month, like this was per month. Write a formula that gives the cost C in dollars of purchasing your home video system and paying for M months of cable service. So there is my function and my variable. So function is C, which is your cost in dollars. And your variable is M number of months. All right, so we know we're gonna have C equals, and then we're gonna create that formula. Okay, above, we were told we had $600 in our piggy bank. So in this example, we don't have a piggy bank, we're spending money. So what is the amount of just you paid this money? It's not dependent upon per month. You're out of the pocket from the beginning. What would I have to do? I'm gonna have to add up all the things that I bought, right? So I'm gonna come over here and look at what my initial expense would be. This is money I spent that was not dependent upon what's going on per month. So $3,000 for the TV, $643 for the DVD, $650 for surround sound, and then a table to set it all on. Does somebody already have that? Oh, money. All right, so this is what I would call my fixed expense. So my fixed expense is $4,616, and then I'm also going to be charged how much? $126 every month. So then I'm going to go ahead and write it with functional notation. So C at M. Again, if you left the 4,616 in front, that's fine. I'm going to go ahead and put the variable term first. Okay. All right, all we're going to do on this example is we are going to set up our function and or define or identify our function and our variable, and then we're going to look at the quiz. All right, total cost C for a manufacturer during a given time period is a function of the number N of items produced during that period. Now notice how they're both capital. So is C or N my function? Cost. The cost is the function of this. So I know that my function is C, which is total cost. And then my variable N. Now, N is items produced, and I'll tell you, here's what we're producing, widgets. So instead of saying number of items, I'm going to say number of widgets. All right, so that's where we're going to stop. So, well, I know I'm going to need, well, I'm going to need you to go ahead and get your stuff and head out, because I'm getting ready to end